we have seen how sigma and pi molecular orbitals are formed. Sigma molecular orbitals are formed by the axial overlap, whereas pi molecular orbitals are formed by the lateral overlap. They undergoes different symmetry when they form. They are having different energy. The lower energy is termed as bonding molecular orbital, whereas the higher energy level is considered as anti-bonding molecular orbital. Now, after that, we have seen the symmetry element, that is the parity. Gyrate in Greek means symmetry or even, whereas ungyrate in Greek means uneven or asymmetry. So this is the molecular orbital, that is sigma s. So this is bonding molecular orbital, and it gives symmetry because it started from the positive sign and ends at the positive sign. It is represented by sigma g, that is g rate, whereas this is s antibonding molecular orbital. And if we connect, it start from positive and it's end negative, that's why it is ungyrate. Then this is sigma p orbital bonding, again this is g rate, whereas antibonding p orbital will be ungyrate. Last but one, this is pi, and if we can see here, this is now symmetrical because if we start from positive, it ends in the negative, it will be ungyrate. And the last one, that is antibonding pi orbital, will be symmetrical, so it is represented by the G rate. Now, our today's session will be formation of hydrogen molecule on the basis of MOT. So before starting the explanation for the hydrogen molecular formation by using molecular orbital theory, let's revise the postulates. So basically it is run by some postulate and we have to follow when we study the bonding as well as anti-bonding formation of the last year lectures, that when the atoms approaches, they should have a proper energy, similar energy. Then and then atomic orbital can interact, can overlap. If there is a difference, a larger difference, it is not possible to interact and form the molecular orbital. So this is the first postulate. Then when we consider the molecule, the interaction of all the electron to the other nuclei or to all nuclei to all the electrons is possible, and it is considered that we have to consider the interaction of all the electron to with all the nuclei. Then every MO will associate it with some sort of energy, and they are comparable with the atomic orbital. So this is related to the energy. Next, when we consider the atomic orbital, we have to consider it as a psi wave function, and when we have to find the probability of electron in that MO, we have to take the square, that is psi square. This is again a classical quantum mechanical formulation. If you want to determine the probability of any electron of psi function, we have to take the square of it. Then shape and the size of whichever the MO form is having some sort of rearrangement with the atomic orbital from which it is formed. And the last one, the electrons are filled according to the F by Hund's rule and Pauli's exclusion principle. So these are the basically postulate. And after that, we have seen the three criteria to form the molecular orbital. The first criteria was they should have, atomic orbital should have comparable energy. If the energy difference between the atomic orbital is larger, the possibility of forming molecular orbital will be very less, or rather it do not form. Then overlapping of atomic orbital should be of a comparable level. If there is no overlap, it will not form molecular orbital. If overlap takes place, two to certain extent it will form molecular orbital. And the last one was the axis of interaction. Whenever the overlap takes place, axis plays an important role. That's why we have two different types of bond formation, sigma and the pi bond formation. Now let's see formation of hydrogen molecule on the basis of molecular orbital theory. Now, if we see the molecular orbital theory formulation for hydrogen molecule, we have to take the help of all these postulate and the summary, that is the criteria to interact. But the molecular orbital, if we take and it is compared with some other theory, which is another theory, that is valence bond theory, that is our next topic, how they compare to each other, which is having more technically easy way to handle, or which have more answer to the energy formation. So basically, whenever hydrogen molecule is studied with respect to two different theories, there will be two different views for it. Now somebody may ask here, what is the need to study the molecular orbital theory in comparison to the valence bond theory? So basically, two different theories are having their own importances, and each theory explain its own role in the bond formation. Means they have their own thinking of the bond formation. So in today's lecture, we will discuss the hydrogen molecule formation by taking the help of molecular orbital theory. Now, so first we have to consider two hydrogen atom. Now again, the two hydrogen, because the hydrogen system is considered as one of the simplest system, and it is again one electron system. When two hydrogens are considered, even we have solved in our previous session that H2 plus ion, again hydrogen is taken. So for this H2 molecule, two hydrogen atoms are taken where one electron is there. Now these two hydrogen atom, when they mix, they will form two different MOs. Obviously, the molecular orbital they will form. One will be bonding and other will be anti-bonding. So basically, when we consider the bonding molecular orbital, energy will be less, and when we consider the anti-bonding molecular orbital, the energy will be higher. Now, why the bonding molecular orbitals are having less energy? The reason is, when bonding molecular orbital form, they form with the maximum interaction of atomic orbital, and they have maximum probability of finding the electron between the nuclei. Since the electrons are having enough space, or the space which is clouded with this electron is more, they overlap with the larger extent, and when they overlap, they are having more or less more stability. More overlap, more stability, and if they are having more stability, then the energy of that molecular orbital decreases, and these molecular orbital are termed as bonding molecular orbital. So this is the representation, that if the low energy we can consider as the bonding molecular orbital, that is sigma 1s, then we will definitely have another molecule for another molecular orbital for antibonding molecular orbital. Now, if we see the structural representation, they will have, definitely these are having the filling of electron, means these are the steps. After getting two different molecular orbitals, we have to fill these two electron with respect to the Aufbau principle. So what is the summary, or what we can take a one line statement from the Aufbau principle? We have to fill the energy from lower to the higher energy. So the filling of electron plays an important role. Whenever we frame different energy level for MO, there will be one higher energy and there will be one lower energy. So how the electrons are filled? So basically, for filling the electron, we have to apply the Aufbau principle. And it is correctly said in the postulate, when the energy levels are formed and we have to fill the electron, we have to follow all the rules, all the classical rules to fill the electrons, like Of-Boy rules or Hund's rule, or the Pauli's exclusion rule. Now, let's see. First one, the hydrogen consideration. We have to consider, or we have to find how the electronic configuration of hydrogen looks like. So basically, this is 1s system. Hydrogen 1, this 1, okay, this is 1 and this is hydrogen 1, 1s1 system. Now we are taking two hydrogen, then and then it will form hydrogen molecule. So these two atomic orbital, that is 1s atomic orbital, will mix to form two molecular orbitals. Now, if two molecular orbitals will form, one will be of lower energy and one will be of higher energy. Now, on which basis these are formed? So basically, these are formed based on how they overlap. Okay, and if the overlap is having maximum or same sign overlap, they will have maximum overlap and energy will be less, and that will be bonding molecular orbital, like this one. So this is 1s system. Now please do not relate this plus sign with the positive charge. This positive sign is nothing but the wave function sign of this 1s. It means the probability of finding the electron in this space is more. Okay, so please do not consider this plus sign as the positive charge. Then you will misunderstand the thing, why positive have more overlap. They should repel if we consider the charges. So basically, these are the probability of finding the electron in a space, and for this 1s it is plus, means the probability of finding the electron in this space is very high. Then this is another another 1s orbital. Now these two are having the positive wave function, means the electron cloud or the probability of finding electron in 1s orbital here and finding the electron at another 1s orbital here is more. When they undergoes linear combination, means linear combination of atomic orbital, they will form some molecular orbital, and this molecular orbital will be this one. Now, as we can see here, since there is positive or the cloud or the atomic orbital is having more energy, more electron density, when they combine to form molecular orbital, they will have a proper maximum electron cloud in the molecular orbital. And since the electron cloud or the overlap of atomic orbital is more, it result in the stabilization of the energy or the stabilization of molecular orbital. And since the stabilization or energy decreases, these are termed as the bonding molecular orbital. So this is represented by sigma. And as we can see here, it can be related with the G-rate and the un-G-rate. So this is the G-rate structure, because when we start from positive to positive, it will end at the positive. So this is the symmetrical structure. So this is how the first molecular orbital form, which is bonding molecular orbital. Now let's see how the antibonding molecular orbital form. So in antibonding molecular orbital formation, let's take the first atomic orbital as positive. Positive means, again, this is the probability of finding electron in this 1s is more, whereas this is another overlap, another orientation where the probability of finding the electron is less. Now one is having positive, one is having negative. When this atomic orbital combine with the linear combination of atomic orbital, we will have some molecular orbital. Since the electron density of 1s is more and electron density of 1s is less, negative sign, they will have lesser overlap. And if they are having less overlap, they do not contribute toward the stability. The stability is less, and since the stability is less, the energy will be higher, and it will form higher energy molecular orbital, which are termed as antibonding molecular orbital. So this one is the antibonding molecular orbital. So this is sigma star. Okay. Now you can text if till this content. If you have any doubt, please WhatsApp on the group, because I enabled the messaging text for this meet. Okay, so you have to follow the WhatsApp link. Do you have any query for this? Up to this, is it okay? Kindly use the WhatsApp group for this. You can text, then we can proceed. Up till this, there is any doubt? This is the picture representation. If you have any doubt, you can text on the WhatsApp group, because I enabled the messaging in the Google Meet, so I am unable to see your question or any doubt. So please, if you have any doubt, kindly message in the WhatsApp group. Or we can, okay, somebody is writing, we can proceed then. Okay, so this is basically the bonding as well as antibonding molecular orbital formation. Now, when the two electrons have the interaction, they will have two molecular orbital, one with the lower energy and one with the higher energy. Okay, somebody is saying can send to this link. No, it's basically the audience almost reach 100. That's why students are unable to join here. So it is technical difficulty. We can't help here now. So let's see the how electrons can be filled in the energy level. So this is the first level. We can see here that both the 1s and second 1s. This is for hydrogen 1 and this is for hydrogen 2. They are equally balanced. What is the meaning? They are having the same energy. They are having same energy because they are of same nature, same chemical property, so they will have same energy. And here we follow the postulate that for the molecular orbital molecular orbital formation, the atomic orbital should have comparable energy. Okay, so here it is followed that they follow correctly. The two hydrogen are alike, they are same. That's why they are having the same energy level. Now, when they mix, they form two molecular orbital. When the orientation with the similar wave function means positive positive takes place, it will form bonding molecular orbital. And when the wave function with the opposite sign mixes, they will form antibonding molecular orbital like this one. This is notation for the electron, one for 1s and one for 2s. Now they will mix to form. This is the mixing process to form two energy level. As we can see here, one energy level is lesser or lower than the ground level or the initial level, whereas another energy level is higher, which is shown by the upper layer. So the bottom line is the lower energy, and it will be correctly represented by sigma 1s, because due to the stabilization, the energy of molecular orbital decreases, whereas the upper one, the stability is less and energy will be higher. It is represented by sigma star 1s. Now this is a simple representation how the atomic orbital mix to form two different energy level. 1s hydrogen means this is one hydrogen atom, this is another hydrogen atom, having one electron, having one electron, 1s, 1s. When they interact, when they overlap, they will form two molecular orbital, one with the lower energy and one with the higher energy. Next lecture that when on the quantum mechanical operator or the formulation, we can determine the average energy. And if we see the average energy, one will be higher, one will be lower. So wave function when mixes atomic orbital, they will have two ranges. One lower energy and one will be higher. So in this case, this is sigma 1s is the lower energy and sigma star 1s is 1s is the higher energy. So this is sigma and this is anti-bonding. Now two electrons are basically we have to fill. So this is governed by some important rule. The Auger principle applies here, which says that electron should be filled from lower energy to the higher energy. Very correct. And here we follow the last postulate of molecular orbital theory, that during the filling of electron in the molecular orbital theory, it should follow the Auger rule. Hund's rules is applied when we are having a higher number of electrons that we have to fill. And what Hund's rule says, it should be paired first and then unpaired first, then it is paired to give the stability for the atomic orbital. But in case of hydrogen molecule, the two electrons will have to reach the bonding molecular orbital like this. This is the placement of two electron in the sigma bonding molecular orbital. Now sigma molecular bonding molecular orbital is okay, that we followed the Auger principle. Hund's rule, it is not applied here. The reason behind is the energy of these two electrons in the hydrogen are incomparable, and when they mix, they decreases the energy due to the overlap and they form bonding molecular orbital. When the energy decreases, they have the single choice to reach the lower energy, and it helps in the stabilization. Okay, and since it helps in the stabilization, this gives lesser energy and more stability to the molecule, and hydrogen molecule is stable molecule. That's why these two electron reaches at the bonding molecular orbital. Now if you see the presentation, there is one mistake in representing the orientation of electron. Do you observe any mistake, or it is okay that both electrons are kept with the upward orientation, and with these two spin cannot be with the same orientation, one has to reverse like this. I again repeating, all these three things I already discussed with the postulates. Okay, and in the postulate, in the last postulate, they clearly says that whenever electrons are filled in the molecular orbital, they have to follow important principle and rule. One we have taken care, that is Auger principle, and the last one is the Hund's rule. One principle is remaining. Anybody? That it is said that it is impossible to have same spin atomic same spin electron in an orbital. They should have opposite spin. So it may be difficult. No, this is not uncertainty principle. This is Pauli's exclusion principle. What it suggests, when we fill the atomic orbital, okay, the two electron cannot have same spin. Okay, because if the spin of the electron, if they are same, means plus of or minus, then they will have overall orientation, overall spin. But the orbitals, when they are placed with opposite spin electron, they will cancel each other, means they will have resultant zero spin. Okay, that's why the orientation should be opposite. They will have opposite orientation. Now the all postulates we followed in the hydrogen molecular formation. The first postulate that the energy should be comparable. Yes, we have taken two hydrogen with the same energy level. Then they mix together to form different molecular orbital. Yes, they mix together to give different molecular orbital. Then they will have the energy respect to the atomic orbital. Yes, when they mix together, they will have two energy level, one lower energy level and other will be higher energy level. So the lower energy level will be termed as a bonding, whereas higher energy level will be termed as the antibonding. Then the filling of electron, because we have to manage the two electron from two different hydrogen atom. When they mix, we have to take care the two electron, how to fill it. So we have to take the help of two classical principles. The first one was the off-by principle, which suggests that the electron should be filled from the lower energy to the higher energy, and accordingly we have filled the two electron in the bonding molecular orbital because they are having lower energy. But when the spin, if we consider, they should be opposite, they should be reverse. So this is taken care by Pauli's exclusion principle. So here the all postulates we are following. And then when the molecular orbital form, it will have some electronic configuration, like the atomic orbital have some electronic configuration, that is 1s1. Now how the electronic configuration of H2 can be determined? This is very simple. Just we have to follow the route from lower to higher always. Okay, as we follow in case of Orbit principle, electrons are filled from lower energy to the higher energy level. Similarly, we have to write the electronic configuration of molecular orbital from lower energy to the higher energy level like this. So this is the electronic configuration of hydrogen molecule. So this is sigma 1s2, sigma star 1s0. So this is electronic configuration. So this is how the hydrogen molecules are formed by following the postulates of molecular orbital theory. Now this molecular orbital theory, which is given, which gives various postulates we followed here. This also gives, this type of energy level also gives one important property to find, that is the bond order. Okay, means we can find the bond order for this molecule or any molecule by using this energy level diagram. This energy level diagram, if we see, there are two energy level. One is having the bonding molecular orbital and one is having the antibonding orbital. So by taking care this bonding and the antibonding molecular orbital, we can easily determine bond order of the any molecule. But for this case we will take the help of the bond order for the hydrogen. Strength, it reflects the basically the number of bond form and also the bond energy. We can relate bond energy, but this is not in the scope for the bond order formation. They will ask you in the university to determine the bond order of the hydrogen. Very easy. We have to just use the formula. This is the formula. Very easy formula. Number of electron in bonding molecular orbital minus number of electron in antibonding molecular orbital divided by 2. That's why energy level diagram is so important. By taking the help of that diagram, I can determine the bond order of the molecule. So for hydrogen, the number of electron in bonding orbital is 2. There is no electron in the antibonding molecular orbital. 2 minus 0 divided by 2. This is 1. Basically, single bond. So hydrogen molecule have one sigma bond.